Welcome to Hot Topics. We're going to discuss in this video, can you work something energized, where you'd have energized conductors and circuit parts. I've received a number of questions pertaining to this subject, and I just thought, well, we'd vary a little bit from doing one of the code changes that is pertinent to you designers and installers. So let's just start with our first illustration here. And it shows a person performing work energized. And notice at the left of the illustration at the top, no lock and tag out. We're not in electrically safe work condition in accordance with Article 120 of 70E. And the only thing you can work energized, any type of system, it's a kind of a give me per NFPA 70E, and it's a Class 2 circuit. It pertains to electrical hazards as defined in Article 100, and the information about this Class 2 circuit is discussed in the informational note, and that's to the right at the very top of the illustration, the kind of give me. Now, we either calculate the calories per centimeter squared, or we use the task group method that is outlined in the tables, and we'll discuss that coming up. But notice we are working energized, and we're interacting. Interacting, by 70E is testing for current, voltage, that kind of thing. Repairing, adding a component or a part in an existing piece of equipment. But we're interacting. And the reason that they kind of gave listed information, in 70E in Article 100, they kind of go through defining, when you can work on something energized and when you're interacting. And then 110.32 further discusses interacting, and 130.2a. Now, those are three important sections for interacting. And if you're not actually testing, if you're not changing a component out, working on energized conductors in some manner, they're terminated, then you're not interacting with equipment if you're not doing that. So you can pass through. That used to be a very big problem. What is considered interacting? Well, that's been straightened out now, and you have those sections there right under the note. Employee is interacting with electrical components and circuit components energized, say. And so basically what they're saying here, at the left of the illustration, at the very bottom, we have a qualified person that's performing work energized in accordance with 70E 130.11. In other words, this person has crossed the arc flash boundary that you see at the right of the illustration at the very bottom. They've crossed that arc flash boundary with the appropriate PPE on, and they're standing in the limited approach boundary, extending the insulated protective arm using gloves, wearing gloves, and using insulated tools. Now, all this is in accordance, if you want to check it out, in 130.4F through G. And then if you want to know more information about these boundaries, then go to the Annex C of 70E, and you can find a great deal of information. So if we're working electrically safe work condition procedures, then we've locked and tagged it out, and these boundaries can be discussed in more detail in 130.11 through 4 if you're dealing with the previous edition of 70E, the 2018 edition. Now, with that thought in mind, we're going to move to the next illustration, which would be illustration number 2. And notice we're working on this equipment, and we're looking at the infeasibility rule. And of course, that rule, can be found in the 2021 edition of 70E and 110.4a, including the informational note that you see in the red references that you see in the illustration. Now, if you're working energized, then you're going to be wearing your face shield and your sock hood. And under certain conditions, you would have to have a face wraparound type face hood that covers your nose, up to your eyes, so to speak. And you can read quite a bit about this rule in 130.7C3, 130.C10B2, and 130.7C10C. You can obtain more information about it. But this person is just testing, and based upon the energy level, that determines the PPE that they might need. But you can read all about this infeasibility rule in 110.4A plus the informational note. And notice some of the examples that they give for infeasibility type work, where you're working infeasibility type procedures. And interrupting of life supports, we wouldn't want to do that. We want to make sure power is maintained. We could work energized. Deactivation, disconnecting of energy alarm systems, shutdown of ventilation in hazardous locations. We might have a Class 1 Division 1 location, and we're bringing in 1 foot of clean air, taking out 1 foot of contaminated air. And we can reclassify from Class 1 Division 1 to Class 1 Division 2. So naturally, it's very important that we do not de-energize the ventilation system, because that could put us back in a Class 1 Division 1, and then the equipment and stuff there wouldn't even be appropriate. Now, deactivation of emergency alarm systems, no, we wouldn't want that, because those alarms are sounded based upon a hazardous condition occur, emergency of some sort, see. So we read all about that in the 2018 edition in 130.2A1 informational note. But if you're reviewing the 2021 edition of 70E, that'd be 110.4A plus the informational note. So this is telling you and giving you examples of what would be considered infeasibility type work, where you could work something energized. Now keep that in mind, and we're going to now move to our third illustration. And here we're dealing with a list of items that could be considered working infeasibility type regulations that you see in that 110.4D is in dog. Now notice test, adjustment, troubleshooting, shutdown of the process machine, operating a greater hazard. And that would be, where you had one machine and computer or process machine, whatever, and if it went down, it would affect the downstream work that you're doing. That would be a situation, see, where you could work energized. I have a client that they manufacture chips, and they cannot let that circuitry go down that supplies the manufacturing of those chips, because that not only would they lose production time, but they lose material time, they lose the time that they invested in performing that work procedure. So you can see that wearing your sock cap or your balaclava, whatever you want to call it, 130.7C3, 130.7C10B2, and 130.7C10C, and we can read all about that. Of course, all your equipment that you wear is explained in detail, starting with 130.7C, and it goes through all of your different types of equipment that you basically wear. And then notice this person. They're either selecting the PPE per table method, and of course we go into that in great detail in our videos for NFPA 70E if you wanted to get on our YouTube channel, James Gray Stallcup, and review this section, you could. Or the entire 70E workbook, if you wanted to do so, it's there. And if you didn't use the table method because the available short circuit current and other items that are listed there just didn't, you didn't meet those parameters at all, you'd have to calculate it then, the calories per centimeter squared per Annex D as in dog, in the back of NFPA 70E. But we would call to your attention that this worker may need a sock hood based upon energy levels in the back of the head and the limited approach boundary. If you wanted to go Annex C and look up a great deal of information is provided there to help you. But it would cover the face, parts of the nose and so forth that needed to be covered in accordance to what section of 70E. And it'd be 130.7C10B2. And that would be in the 2021 edition of NFPA 70E. Now you have all your references here where you want to work something energized. But just let me point out something, especially to our electricians, our maintenance electricians, our construction electricians. If you're, say that you're troubleshooting, and maybe not troubleshooting, you're just trimming out. Always start at the very back of the dwelling unit, away from the panel board, or check all your breakers, make sure they're turned off, and then make sure that you test your circuitry. I always had a wiggy with me back in my days, and we even if we were doing engineering work or installation work, I always checked it just to make sure. And you know what OSHA says, what 70B in chapter 7 says, a circuit is considered not de-energized, but energized until you check it to make sure it's de-energized. So this just kind of outlines some of the infeasibility situations that you might get into. Now, keeping that in mind, we're going to move to now the next illustration and take a look at it. Now, this illustration, it deals with the same rule of testing and adjustment. We've kind of looked at that, so we're ready now to look at our last illustration. Excuse me for calling up the wrong one. Now, this fourth illustration that we're looking at deals with if you want to deal with the invisibility rule that we just looked at. Notice to the right of the illustration at the top, it refers you to 110.4b, and you can go through B, C, and D in there and learn more about it. But we're wanting to know in this illustration, do we need to take out an electrically hot work permit or electrically energized work permit? This gives you the exemptions. Maybe you could say exceptions to the rule. But notice some of these examples of the exceptions or the exemptions from the rule is test, adjustment, troubleshooting, voltage measuring, infrared inspections, where you'd stand in the limited approach boundary and do your infrared that's required to do once a year in accordance with 11.7 of NFPA 70B, if you want to look it up. And then, of course, the restrictive approach boundary, you're not crossing it. All you're doing there is just using an insulated tool with the insulated arm passing into that area. And then, of course, your general housekeeping rules, you're not allowed in the restricted approach boundary. And I think that's 130.8I that you would look at there. So we're really looking at big time requirements in 130.2C as in car when we review this particular illustration we're looking here. And yes, it is 130.8I where it says perform housekeeping rules. Now, these are the requirements where you can work something energized. And if you're working energized, get all your ducks in a row and make sure that you follow it, because these are the main illustrations with these sections you need to know as a company, or if you're an electrician, to provide your safety. And again, just let me caution you, make sure you test circuitry before you work on it. Of all the lawsuits that I see and people getting hurt or killed, they just haven't followed their procedures. They haven't checked the system to make sure it's disconnected. You know, one time I got hit pretty bad because I disconnected. I went to the motor after I disconnected the disconnect, and one of the blades were broke on the disconnect. And of course, it backfed through the windings of that motor, and man, it lit me up like you wouldn't believe. But see, I didn't follow procedure. I just disconnected it. My tester was in the truck, and I didn't follow through. But again, as an engineering firm I work with, or a contracting firm, I always learned, check my circuit and make sure it's dead. Make sure I'm not getting any kind of a damaged breaker that might be feeding one leg, or a blade that has broken inside a switch, disconnecting switch, for example. Check it out and play safe. Now, my name is James Gray Stallcup, and this video on working something energized, I hope it's useful to you. And again, thank you for watching our videos. And I'd like to remind you again, if you like our videos, hit that subscribe button, and they'll come to you each week as we provide one for you each week. Again, I thank you for watching this video.